Welcome to this explainer. Today, we're going to completely dismantle some of the most common misconceptions out there about specifying aluminum cable trays and make sure you've got exactly what you need to know for your next project. You know, we see it all the time in structural and electrical engineering. A material looks absolutely perfect on paper, but when it meets the harsh reality of physics and environmental stress, well, it tells a totally different story. So today, we are cutting straight through the noise. Okay, let's just dive right into the elephant in the room, the massive immediate appeal of aluminum. It's literally 30 to 50% lighter than steel. I mean, that is a staggering difference. If you're a buyer stressing over freight and shipping costs, or a contractor thinking about the sheer back-breaking labor of hoisting hundreds of feet of tray into a high commercial ceiling, that number is a massive green light. It's exactly why aluminum is so often the default choice when you're first sketching out a project. But right here is where we had a critical twist. As the old saying goes, lighter doesn't mean stiffer. The whole perception of that weight advantage flips upside down the second your cables are actually loaded into the tray. It is so incredibly tempting to just look at a bare, empty aluminum tray and celebrate all the weight you're saving. But as engineers know, deflection, the bowing or sagging of the tray, is the real enemy here. Just because a piece of metal is super light to carry across a room doesn't mean it has the inherent structural rigidity to span long distances without sagging under pressure. To help guide your next specification, we're going to cover a quick agenda. First, the aluminum weight myth. Second, aluminum versus steel. Third, the corrosion factor. Fourth, a pre-specification checklist. And fifth, global industry standards. All right, let's kick things off with Section 1, the aluminum weight myth. So here is the true mathematical reality behind your spec, the real dead load calculation. Just imagine a massive run of really heavy, thick copper power cables, or maybe thousands of tightly bundled data wires. Once that payload is actually sitting in the tray, the mass of those cables completely dominates the load calculation. That huge initial weight advantage of the aluminum tray, it shrinks down to almost nothing. The weight of those cables becomes the primary downward force hammering your support brackets. The fact that the tray itself is a few pounds lighter is honestly negligible in the grand scheme of the math. And this is exactly why a lighter tray doesn't automatically mean you get to stretch out longer spans between your supports. Moving right along to Section 2, aluminum versus steel. Now, you and I both know it's never just about the raw metal sticker price. We have to evaluate the exact real-world trade-offs between aluminum and steel when it comes to structural stiffness, handling impact, and the final installed cost. Because aluminum is generally softer, you might actually need thicker gauges or completely different structural profiles just to match steel's stiffness, which totally alters how you plan your spans. Then think about impact. If you're in a heavy industrial plant where a rogue forklift or swinging equipment is just a Tuesday, steel is going to absorb that physical strike way better than aluminum. Finally, there's installed cost. You've got to carefully balance your initial savings on labor and freight against the very real possibility that you'll need to buy and install more frequent support brackets. It's a tricky three-way balancing act. Which brings us to Section 3, the corrosion factor. Okay, while aluminum is definitely celebrated for its fantastic natural corrosion resistance, a truly successful specification means identifying exactly where it holds up and, more importantly, where it absolutely doesn't. Aluminum forms this really cool natural oxide layer that protects it beautifully in a lot of outdoor or wet environments. But you can't just assume it's some invincible superhero material everywhere. If you drop it into a facility dealing with specific harsh chemicals or highly corrosive airborne particulates, yeah, it can still degrade. You have to actively identify the precise chemical reality of your specific site instead of just leaning on broad, generalized assumptions. Let's turn to Section 4, the pre-specification checklist. Before you finalize any spec, you absolutely must walk through this 5-point framework. It's a lifesaver. Span dictates how many support structures you have to buy. Corrosion dictates if your material will even survive the year. Bonding ensures the electrical safety of your entire system. Thermal derating protects the performance of your cables. And finally, access guarantees your maintenance teams aren't totally locked out of the system later on down the road. Honestly, if you miss even one of these steps, the entire system becomes vulnerable. Let's actually zoom in on Step 4 for a second. Thermal derating. This is such a crucial calculation for managing heat dissipation across your cable management system. Think about it. When you run multiple highly active cables tightly packed together in a tray, they generate a lot of heat. If that heat can't escape properly, the electrical efficiency of your cables actually drops, meaning they have to be derated. If you overlook critical nuances like this or skip proper electrical bonding, even the highest quality, top-tier aluminum tray can turn into a completely ineffective and really costly liability. Finally, let's wrap things up with Section 5, Global Industry Standards. To see these principles actually applied in the field, we can look at Shanghai Xinma Busway and Cable Tray Company Limited. They really demonstrate these concepts in action with a massive portfolio, everything from cable tray systems and busways to seismic bracing and intelligent cable management solutions. But what's really crucial here is where these systems actually end up going. We're talking mission-critical environments, data centers, complex rail transit systems, harsh industrial plants, and giant commercial buildings. These are high-stakes arenas, right? Getting the specification wrong in these places simply isn't an option. And how do you know you're getting it right? By checking the standards. Knowing your products comply with really rigorous global standards, like IEC 61537, NEMA VE1, BSEN 5085, and GB 31251, proves your specification is backed by serious industry benchmarks. These aren't just random boring letters and numbers. They represent exhaustive physical testing for load limits, electrical continuity, and environmental resilience. When a manufacturer actually commits to meeting these standards, it literally takes the guesswork entirely out of your specification process. So, as we wrap up this explainer, I want to leave you with one final, slightly provocative question to challenge your next project. Ask yourself, is your dead load calculation truly accounting for the massive weight of the cables rather than just the weight of the tray? Are your engineering models relying on the appealing, lightweight nature of an empty aluminum tray, or are they built for the heavy, uncompromising reality of fully loaded cables? Rely on the data, ask these tough questions, and I guarantee you'll engineer stronger, safer systems every single time. Thanks for joining me.